Okay, so in this section of the video, we're going to use this tool called mocap to look at our data from the motion capture. Okay, so this interface from mocap opens up like this, and we're going to import one of our TRC data files here. So in this case, it'll be lab section 305, no pump. And when we import this, we can go ahead and play it. We can see our person, he's kind of, his orientation is such that standing up is in the Y direction, and we can see him picking up and throwing the ball, right? So we need to come over to our label, and I want you to look at two things. LFIN, this is, if we click on this little button here, this is going to show us the track, and if we click on one of these buttons, it's going to show us, drag this radius slider over, it'll show us what point we're looking at, right? So if we increase the radius of the tracked point, make it red, you can see that this is the tip of the person's hand. So L fin and R fin are the two things we want to track. Okay, so R fin, I'm going to make that red and blow it up a little bit so we can visualize how this person's hand is moving as through time, right? Okay. So the other thing we can do is come over here and take Elfin and drop it into our this graph editor, right? And Rfin, we can do the same thing. And we're going to look at this and say, looks like Elfin does a better job of tracking over the entire history of time. So I want to look at this and say, let's just take out Rfin, and we'll use Elfin as the ground truth, right? This is what we will be tracking to measure this person's mechanics. Okay, so the other thing we got to do is drag this time slider on the bottom, and looking at our figure, let's find out where the person is picking the ball up or contacting the ball, bringing the ball up, and then letting go of the ball. All right, so let's try to think about that in terms of just visualization on our figure to the left, and let's try to also visualize this on the y-axis plot. So we can see that the person picks the ball up around here, maybe around frame 1029, right? And on the y-axis, we see that this corresponds to this little local minima, this little dip region over here. Okay, so I'm on a separate piece of paper. I'm going to write down frame 1029 pickup, and then I'm going to drag over and see where the person throws the ball. So come up, and we're going to say maybe like right there, the person probably releases the ball. And if we look at the y-axis plot, you can see that that happens when we have this sudden change in y location, right? We've thrown the ball down and then we stopped. So I'm going to mark that frame as 1245 is release. Okay, and then I'm going to go through the video real quick, and we'll see where they pick up the ball again, about right there, probably picked it up. That's frame 1367, so 1367 pickup. I'm just marking this in my paper, and when I look at the y-axis, it looks like at the beginning of this like trough region is where we pick it up. So I'm going to slide over and go to the next part of this y-axis graph over time, and I'm going to guess that that is where we're releasing the ball. Let's see if it's true. That looks right to me. So at these little dips right down here is where we release, and that's 1583. Okay, and then we'll go over to this local minima here. It's probably where we pick it up. Okay, 1693. Come over here, 1907. And I'm just going through getting the frame numbers for the local minima and this point where we think it, the ball is most likely being released. Let's come over, pick up here, 2009. Release, 2230. Pick up again, 2343. And then released finally at 2576. Okay, so from this data, we've found that Elfin gives the best, the cleanest tracking data, and we found the frame numbers corresponding to the pickup and release of the ball. So let's go and use that. What we're going to do is come over here to the CSV data, and we're going to open the corresponding file. And we want to come up to the top of this thing and find the name that corresponds to Elfin, right? Let's go over, it's like DJ, something like this. There's Elfin there, okay. We want to make sure that we use the bone marker and not the bone, all right? So Elfin, the Y position of Elfin is what we want to track, right? And we can see that from Mocap. It says that the Y-axis is the kind of what has the most action, right? And the X and Z axis just look at the translation of the hand along the parallel to the floor, and we don't care about that stuff. In terms of energy, we talk about if the ball is being lifted off the ground, right? These kind of things. This is where we're going to get our motion from, this Y-axis, right? Okay, so in our Excel file, let's come over and extract Y, copy it, and in the Excel sheet that I give, you can paste in that position data, right? Go to the tracked hand tab of the Excel file that I uploaded onto the modules, Lab 4 modules, and go ahead and go to the tracked hand tab and paste that into the Z location. And then the other thing we need is the time. So the time is here, and the frame number would be good too, but honestly, we can just do that in Excel. We'll make a new insert over here, and we'll call this frame equals 0, 1, 2, and then just let it auto-populate. There we go. All right, so we should have 2741. Yep, 2741. Cool. All right, so the length unit here is given as centimeters, right? So over here in our ball slam data, I want to make sure that this thing is in centimeters. Okay. And then we can go centimeters to meters. What's that? So let's redo this thing into meters. We got Z in meters. And that's just equal to this times our conversion. Okay, and make sure that this thing is just a variable that doesn't change with the money signs. Yeah. Okay, cool. All right, so we want to find the velocity over time. That's one of our first steps here. So let's go velocity of Z. How do we get that? Well, we can use this central difference theorem. Say this is this Z2 minus Z0. Right. Divided by the time. T2 minus T0. So we find our velocity for basically all these points, and then we want to go through and talk about what frame numbers correspond to pickup and release. All right, so we just want to know if the person is in contact, right? So the person is not in contact with the ball until frame 1029. So let's go down to 1029, and then we'll change this to a 1. And then the ball is released at 1245. Come down to 1245. Make that a 0. Double click so that the rest of them are 0 until we pick it up at 1367. And notice we're just going to repeat this until this pickup and release, where If the ball is in contact with the person from pickup to release, then there's a 1, and if they don't have it in contact, then it's a 0, right? So we'll just keep doing this. Okay, cool. And that is how we're going to analyze the motion cap data from Mocha and the corresponding marker location. All right, we'll use this basically this data later to talk about how much work was done by the person over time. All right, how much power and work did the person do by picking this ball up? All right.